All right. Hello, students. Um, like I said in class, I am God, obviously, Thursday, Friday, but we still have to learn some math. So we're still going to go over some 9.2 stuff. I'm going to try to slim it down a little because no one likes to learn from a laptop or from a device. And I definitely do not like teaching from online, but we still got to get some stuff in your brains. So I'm going to break this into two parts. Finish both these lectures and please work on your homework afterwards. Do not give the sub trouble because if you do, I will know about it and I will reprimand you. But we have 9.2 opener right here. This is recap from 9.1. So let's look at this first set of numbers and we're going to create a sequence coming out from it. So we have 3, 7, 11, and 15. I see that the difference happening here is plus 4. So my common difference would be a 4. And then from here, like we got a lot of practice last time, writing an equation of a sub n equals 3 plus n minus 1 times the common difference of 4. All right. And then what can I do? I can distribute out this 4 to give me 4n minus 4. And then I can also combine these like terms, these constants, to give me a final answer of a sub n equals 4n minus 1. Beautiful. All right. Next one, let me zoom out a little. There you go. Oh, also, if you want to pause before I keep yapping, you can go ahead and try to solve these on your own. And then afterwards, maybe try to see if your answers match up with mine. Number 2. So these are gross and decimals. I'm going to get rid of that. I don't like it. So why don't I do 24 over 2? 9.5 into a fraction would turn into what? 9 times 2 is 18. Plus 1 would be 19 over 2. 4 times 2 is 8. Plus 1 would be 9 over 2. So looking at this, I see a difference right here of obviously it has to deal with n, but I can see that maybe if this is my first term, then my n would be what? N times 5, right? Because if n is 1, 1 times 5 would be a 5 reduction here. Moving to the next one, I see it's the second term, but this this pattern that we made earlier still works of where n times 5 when n is 2 would be 10. So 24 minus, when n is 1, 24 minus 1 times 5 is 19. And then 19 when n is 2. 5 times 2 is 10. So 19 minus 10 would be 9. All right. So from here, we would create an equation. Right. I have my first value, 24 over 2, and then minus 5n. And all of this, because the 5n's also existing in the numerator, would have to be over 2. So we could go ahead and simplify this even further by combining these denominators to have a cleaner looking equation that says 25 minus 5n all over 2. Okay? Oh, sorry, not 25. 24 minus 5n. Lastly, number 3. Okay? First thing I would note, this sign is changing. We have an oscillating sign, positive, negative, positive. Automatically, that is telling me that I'm going to have a -1 to the n plus 1 or something like that. Okay? Next thing I would notice is that my 1's in the numerator do not change. So that's going to stay. We're not going to touch that. It will most likely be this in the numerator. And what is changing is the 3 in the denominator, 5, and the 7. All right. So if we're looking at this, like I said earlier, this 1 is not changing on top. But the denominator, how are we going to get this 3? Right? I know I'm going to have to deal with an n as like our term change, right? So we know there's going to be an n here. And then there's also going to be a plus 1. So my inclination would be to have this 2, because when n is 1, we get the denominator of 3. When n is 2, we get a denominator of 5. And then, oh, it's a little cramped. When n is 3, we get a denominator of 7. Okay, so we see that this is working. Let me just move it over a little bit so that we can have a little more space. But in the numerator, I have -1 to the n plus 1 to have an oscillating sign. And then in the denominator, I have a sequence of an increase of 2 every term for the denominator. Nice. All right. Moving on, we have our opener continued talking about summation and stuff. So again, pause the video if you want to try them out first. But number 4, okay, one of the properties we learned from last class is that if we have a constant, only a constant in the front. So right now, what we're seeing is a constant in the front, and this is the property right here. If it looks something like this, which it does, then what we can do is we can do n times c. So here in our equation, we have a 3 and a 4 as our stop points in the summation. So I can just do 3 times 4, giving me an answer of 12. All right. Next one, I could just plug these in. When n is 1, right, it would be 1 squared, which is just 1, minus 3 times 1. So that's my first set. Next, when n is 2, I have 2 squared, which is 4, minus 3 times 2, which is 6. Next set, when n is 3, it's 9 minus 9. That'll just become 0. Keep going, go all the way up to 6. Your answer should be 28. Okay, so let me put a little ... here. There we go. All right, and lastly, this is just another practice for you. So hopefully you paused it and you tried it yourself. Your answer should be 4.9 from just plugging in 0, j equals 0, j equals 1, j equals 2, all the way up to j equals 5. And then you will end with 4.9. Cool. So here are the final answers for the last part of our opener. Moving on, finally getting into 9.2. Okay, honestly, still a little bit of review from previous class. I think we're definitely getting a nice slow start to this year, this new semester. So arithmetic sequences and partial sums. So our objective in this lesson will be to recognize, write, and find the nth terms of arithmetic sequences, find nth partial sums of arithmetic sequences. So partial sums. All right, finite sequences, we've already talked about this, but they come in 3 flavors. They're either arithmetic, geometric, or neither. Nice. Okay. Next page, arithmetic sequences. This is also decent bit of review, right? What is the common difference that's happening here? I see that it's a +5. The second one, what is the common difference that's happening here? -16, right? So our general formula, as we've been using a whole lot recently, is a sub n equals a1, the first term, plus n minus 1 times the common difference. Okay, memorize that. Memorize. All right, guided practice. You guys can go ahead and pause. You can also work with your friends if you want, but I'm assuming most of you just put your AirPods in and are just gonna times quadruple speed this. But determine whether the sequence is arithmetic. If so, find the common difference and the general term. So number 2 right here. What is happening? What is the difference I'm seeing? I'm seeing a lot of +3, right? So my common difference is 3, and it is for sure arithmetic. Okay, so now it says if it is arithmetic, go ahead and find the common difference, which we just did, and the general term. So the general term is just the sequence. So we have a of n equal to the first term, which is 4, plus n minus 1 times difference, which is 3. We can distribute that out to give us 3n minus 3, which will become, after combining like terms, 3n plus 1. Cool. Nice. All right, the next one. What am I seeing here? 80, 40, 20, 10, 5. Okay, so I'm seeing what the difference here is 40. Difference here is 20. Difference here is 10. Difference here is 5. Okay, that's clearly not arithmetic because it looks like it's being divided by 5. So we can just say not arithmetic. Not arithmetic. Very cool. And let's move on to the next one. All right. So we have 3, 5 over 2, 2, 3 over 2, and 1. Again, this is really gross when stuff is just like in different forms. So I'm going to go ahead and make everything into a fraction. 6 over 2, 5 over 2, 4 over 2, 3 over 2, and yeah, so on. Okay, so what is going on here? Looks like my difference, oh, look at that. Looks like it's just a 1/2. So that is definitely looking arithmetic to me. So then I would just write down, right, what is the common difference? That is going to be minus 1/2. And now to create a formula for us, we have a of n equals first term, which is 3, plus n minus 1 times the common difference of negative 1/2. Why don't we distribute that out? That gives us 3 plus negative 1/2 n plus 1/2. And then let's combine like terms. Final answer will be a sub n equals negative 1/2 n plus 3 over 2. Let's just get it all into a fraction. So let's say 6 over, oh, sorry, 7 over 2. 6 plus 1. All right, cool. So hopefully that wasn't too bad. Let's move on. We have write a rule given 2 terms. This is something new we're looking at. So we have 2 terms of an arithmetic sequence being a of 8 equals 21, a of 27 equals 97. Find a rule for the nth term, then write out the first 5 terms. Okay, so what we're going to do here, it's not too tricky either. What we first want to do is take the n terms and subtract them from the biggest to smallest. So right here, I have A27 and A8, right? So I'm going to take 27, and then I'm going to subtract 8. And that's going to give me 19. Okay. Next step that I'm going to want to do is I'm going to take the product, I guess we could call it the product of both of those, and then subtract those as well. So I have 97 minus 21 is going to be equal to 76. Okay, so with these 2 parts, what you can do is actually you can divide these. 76 divided by 19, that is actually going to give us 4, which is our common difference. Okay, very cool, very exciting. We love math. Knowing this, looks like we have a lot of parts. We're going to do a of n, a sub n equals a1 plus n minus 1 times 4. Okay, so we're almost done. The way we can find what a1 is I can plug in, like it's a lot kind of similar to like with an equation, right? I can plug in some of the stuff I know. So why don't I plug in a of 8 is equal to a1 plus 8 minus 1 times 4. Okay, and then a of 8 would be what? 21, right? So we have 21 equals a1 plus 8 minus 1. This is going to turn into a 7. 7 times 4 is 28. And then we're going to move this. Oops. Hold up. Okay, so this all together will turn into 28. I'm going to move this over to the other side, giving me negative 7 equals my a1. Okay, so lastly, we can plug that into our final equation. A sub n equals negative 7 plus n minus 1 times 4. All right. The last part of the question asks us to write out the first 5 terms. Obviously, we know what the first term is. It's 7, negative 7. And then we know that the common difference is going to be just 4. So -3, 1, 5, 9, 13, 2. Oh, wait, oops. We did an extra one. Yes, those are the first 6. Cool. That is the final answer for that. All right. So why don't we move on to the next guided practice? So go ahead and pause. You can try this on your own if you want. But let's quickly get this done. We have 36. So we have A4 equals 16 and A of 10 equals 46. Like we did earlier, I'm going to take my ends and then I'm going to subtract them. Cool. Next, I can take my, I guess we called them products last time, right? 46 minus 16 is equal to 30. Nice. From here, I'm going to divide these to give me 5, which is my difference. My common difference, 5. Okay, next, A sub n, I can start getting this formula ready, equals A1 plus n minus 1 times 5. All right, let's plug in. I mean, it's always easier to just do the smaller one. We have A of 4, which is 16, is equal to A1 plus, what is that? Oh, sorry. Okay, sorry, brain fart. N equals 4. 4 minus 1 times 5. 4 minus 1 is 3. So this all together would give us a 15. And then we can subtract this 15 over to the other side, giving us an answer of 1 equals A1. Awesome. So why don't I go ahead, up space, yep. Go ahead and write this in to our original equation. We have 1 plus n minus 1 times 5. And let's write out the first 5 digits of this. Our first term is 1, and we're seeing differences of 5. So this would be 1, 6, 11, 16, and 21. All right, so go ahead and try this next one too. We have A3 equal 19 and A15 equals negative 1.7. So 15 minus 3 would be 12. And then we have negative 1.7 minus 19 is equal to negative 20.7. If we divide these, we do get something kind of gross. Negative 20 over 7.7 over 12 would give us negative 1.725. Yeah, very gross, but you know, we can make it work. A of n equals A1 plus n minus 1 times negative 1.725. And then let's plug in one of our values. We have 19 equals A1 plus 3 minus 1 times negative 1.725. And then if we combine all these, right, 3 minus 1 is 2. 2 times negative 1.725 is a number, but subtract that from 19, you will end up with an A1 of 22.45, right? Plug this into your equation, and you will get first 5 numbers of 22.45, 20.725, 19.17. Oh shoot, did I mess up? Okay, yes, it keeps going. Sorry, I can't tell what my decimal looks like versus my period. Something's wrong. Something's messed up in there, but go ahead and take a look. This is how we are finding the general term and the first 5 terms of an arithmetic sequence given 2 terms. All right. Well, before we jump into the next one, I'm going to take a quick little break because I have to pee, but you guys can take a quick break, do a jumping jack or something. But yeah, see you in part 2 of 9.2.